Two fractions that name the same amount are called equivalent. Okay. How does the LCD of two fractions help you compare the fractions? Who can answer that? Quinn.
The LCD tells you what is also in common denominator, and so when you find out the LCD, you can change it to that number and have the same number, and then you can.
Okay, if you have two fractions, you can use the LCD to rewrite the fractions so they have the same denominator. And LCD is very closely related to what else? LCM, least common multiple. So the LCD is the least common multiple of the denominators. Do you guys understand? So when you're trying to rewrite your fractions in equivalent forms that you can compare fractions that have like denominators, you're using the LCD, and it relates to LCM. Okay? So when you have two fractions with a common denominator, how do you compare them? Edipoji? Yes, by looking at the numerators. So you can't really make a comparison. There's some shortcuts, but you can't really make a comparison if you don't have a common denominator. Okay? There are a couple tricks, and we'll talk about that shortly, but they only work in special cases. But if all else fails, rewrite the fractions so they have a common denominator, and that's a method that's always going to get you the answer. Okay, so find each missing number. For number 2, who has number 2? Jayla. 4, very good. So the answer is 4/8. How did you get that? What was the factor that you used to go from 8 to 4, or 16 to 8?
Well, 6 divided by 2, how they're related, you have to multiply, or you have to divide by 2.
Right, so we divide by 2, divide by 2, that gets us 8, that gives us 4. Okay, number 3, who's got number 3? Somebody I haven't heard from yet? Nathan, go ahead. Number 3. 8 tenths, very good. And how did you do that?
Because I know that 10 divided by 2 equals 5.
Right, so if I can divide 10 by 2 to get 5, I can also say 5 times 2 gives me 10, right? So if I can multiply that out, then I could do the same to the numerator. So 4 times 2 will give me 8. Okay? All right, who's got number 4 for me? Who can explain number 4 to me? Yes, Jason.
24.
24, very good. And how did you get 24?
6 times 4 equals 24.
Right, so we know that 1 times 4 equals 4. So 6 times 4 gives me 24. Okay? Now number 5 is pretty easy. Who's got number 5? A day. What's number 5? We're supposed to use less than, equal to, or greater than. Which one are we going to use?
Greater than.
So what's greater than? So what you're saying is correct. You're saying 5/12 is greater than 3/12, and a lot of students have been saying this all day, but that's not what the question is asking you. That's not what was there. How would I fill in what's missing here? What would go there?
3/12 is less than.
Nice, thank you. Less than. Less than. So be ready to answer the question that you see. Even though these have the same meaning, be careful. Okay, so does anybody remember the shortcut? It said if the denominators are the same, you compare what? The numerators, right? Now there's another shortcut here. You don't have to rewrite these as a common denominator. Does anybody remember the shortcut if you have like numerators? If you have like numerators, does anybody remember that shortcut?
Nope.
Yep. If the numerators are the same, but the denominators are different, there's a shortcut that was brought up before. Sophia.
Compare the denominators.
Uh-huh.
Like for number 6, with 1 6 and 1 quarter, 1 quarter would be greater.
Right. And if we think about it, let's think about a pizza, right? So if I have two pizzas and they're the same size, right? And I cut my first pizza into 2 parts, 2 equal parts, okay? And then I take my second pizza and I cut it into 4 equal parts. The slice from the first pizza that are 2 parts are how much? How big is each slice? 1/2, right? The other pizza that I cut into 4ths, okay, each slice is how much? 1/4, right? So the numerators are the same, but Which piece is bigger, 1/2 or 1/4? 1/2 is bigger, right? So if we think about it that way, if the numerators are the same and the denominators are different, the denominator, the pizza, in the example I gave you, the pizza that's cut into more slices, those slices are less. Does that make sense? Okay. But you can test it out. If you don't understand the shortcut, we can rewrite these. 1/6, what's the LCM of 6 and 4?
12.
A lot of people want to say 24, but the first multiple they have in common is 12. And this relates to what we're doing today. So the numerator would be what? 6 goes into 12 how many times? 2. So 2 times 1? 2. And then 4 goes into 12 how many times? 3 times 1? 3. And we can definitely see that 2/12 is less than 3/12. Okay, so if you didn't understand my shortcut, I showed you the method that always gets you there. Oli, you have a question? Yeah, sign out the sheet. Okay, any questions about the warm-up? What you'll learn to add and subtract fractions and mixed numbers and to solve problems involving fractions and mixed numbers. Why learn this? Sometimes you want an exact answer when you add or subtract fractions and mixed numbers. When you add or subtract fractions that have common denominators, keep the denominator the same, add or subtract the numerators. So let's go ahead and walk through this. Write this out, write the whole thing out all day long. Different cohorts have been having problems with problems they think that are easy. Now this one's starting out very easy, but a number of 7th graders have hit stumbling blocks throughout. So even though you think it's easy, I want you to write the problem out and the answer. When you're done writing out, put your pencil down. And don't just write your answer out. There's not much value to that. Write out the question and the answer. Who can explain the answer to me? A day.
1 plus 5.
Okay, so what's my fraction going to be?
6/8.
6/8. Now, is that your final answer?
No.
Because I'll tell you what, on a multiple choice test, they'll give you that as one of the answers and you'd be wrong.
What's this?
There's a better answer. What's the better answer?
This one.
Mhm.
So that would be 3/4.
Throughout the day, a lot of students will get that answer, but that's not the correct answer. 6/8 is not the correct answer. 3/4 is the correct answer. Yes, Lola?
Is that addition?
That's addition. We're doing add or subtract right now. We're not doing division or multiplication at all today. Do you have a question about this, or do you understand it? Okay. Are we good?
Wait, no. No.
Okay, what's your question?
You might even want to write that down so I don't get it wrong next time.
It's okay. It'll be in the notes. Make your corrections. We're going to quickly move along. I need you guys to answer these 3 questions. These are easy. I'm trying to get you started so we can work on the more difficult ones. Who's got the first one? Taylor. What'd you get? 4/5. Here's how I need you to show your work. There's a reason why I want you to write it out this way, because when you get to algebra, this is as far as you can go. So you need to write that and understand that. Do you understand?
Yes.
So I need you to show your work this way. I'm trying to get you guys ready for more advanced math that you're going to be seeing this year. And so if you're not showing your work, you're going to hit a stumbling block. Next problem. Who's got the next one? Somebody I haven't heard from yet. Trinity. 1/4. And that's good. You actually went and reduced it because I had a number of students throughout the day that gave me other answers. If you had another answer besides 1/4, you probably didn't simplify it all the way. Okay? Now, when we take the difference of my numerators, it becomes 4/16. 4 and 6, the GCF of 4 and 6 is 4. So if I divide the numerator 4 by 4, I get 1. If I divide the denominator 6 by 4, I get 4, so 1/4. Are we good? Okay. And then the last one, who has the last one? Yes, go ahead. 1 whole, very good. So the last problem is 1 whole. So 1 plus 3, the numerator becomes 4, so 4/4. And we know that when the numerator and the denominators are equal, it's the same as 1. Understand? Any questions about that problem? Moving right along. Now we're going to go to same denominators for mixed numbers. So remember, I'm doing 2 lessons today. I'm showing you the fraction, and then I'm showing you how to deal with it with mixed numbers. So to find the sum of 2 mixed numbers with fraction parts that have the same denominator, you can first add the fractions, then add the whole numbers. Now I recognize that there's a couple other methods. I'm just going to discuss this method. If your method works and it gets you the correct answer, fine. But I'm just going to discuss one method today. So quickly, I'm going to read this, and then I want you guys to work this out. Same denominators. Cross country. You're training for a race. On Monday, you run 2 3/4 mile. And on Tuesday, you run 4 3/4 mile. What is your total mileage? So first of all, what's the word total mean? What operation are we thinking about when we hear the word total? Go ahead, Nicole. Addition. So we're taking the sum of these 2 mixed numbers. Go ahead and do it. No. If you can't see, go ahead and move up. Lola, if you can't see, you can move up. I see you squinting back there. Here's an open seat right here. Okay, who can walk me through this? Somebody I haven't heard from. Kayla, can you walk me through this? What's the first thing I'm going to do?
The first thing I did, I added the fractions.
Okay.
3/4 plus 3/4. They both have the same denominator, so it stays the same.
Right.
Just add the numerators.
Yes.
So it'd be an improper fraction, 6/4.
Right. So 3/4 plus 3/4 is 6/4, correct? And then what else are you doing?
You gotta make it a mixed number.
Okay. So what about the whole numbers? What about my whole numbers here? I got.
Add those.
Okay. So what does that become? I got the whole number. 4 and 2 becomes 6. So here's where we're at right now. Okay. Does everybody understand how we got to this point? Okay. Who said no? Okay. So here's what we start out with: 2 3/4, 4 3/4. The 2 and the 4, the whole numbers, we can just put those together. That becomes a 6. Now 3/4 and 3/4, they have the same denominator. So we keep that denominator, but then we add the numerators. So then we get 6/4. Okay? Any other questions? Yes?
We don't do anything if it's improper.
Okay, no, we're getting there, and Kayla's going to continue. Go ahead, Kayla.
Then you gotta make 6/4 into a mixed number.
Yes.
By dividing, you see how many times 4 can 1 is 6?
Yes.
It's 1, so that's the whole number. And then the leftover amount will be the numerator.
Okay, and what's the leftover amount?
2.
So,
it'll be 1 and 2, 4.
nice.
That is not simplified.
Okay, so you can simplify this right now. I didn't in my work here. So I'm going to continue from here. Anytime I have a mixed number, you realize that's just the whole number plus the fraction. So I can always rewrite a mixed number as the sum of the whole number plus the fraction. Do you guys see that this is equal?
No.
So 6 and 6/4. Any mixed number is just a whole number added to the fraction. So this is 6 plus 6/4. Anytime. This is 2 plus 3/4. Do you understand? This is 4 plus 3/4. Those are added. But they put them together. They throw out the add, and they just want you to understand that those are together. Okay? So I just rewrote it this way so that we can show 6/4 becomes 1 and 2/4. But now I have a whole number and another whole number I can add to. That becomes 7 and then 2/4. And then the step that Kayla was about to talk about, the 2/4 simplifies to 1/2. Okay? Yes, Adipogio, question.
Make the two numbers improper fractions.
Yes, but that's the other method. We're not going to talk about that right now. Okay, so moving right along. Go ahead, find the sum or difference of each of these sets of mixed numbers. Yes? Hold on.
What time is it?
Okay, does anybody have the first problem? Tori, do you want to give this one a try? What did you get?
I got 4 and 1/3.
4 and 1/3. Very good. So let's take a look at this answer. Here it is. So if you take and you add your fractions together, she gave you the final answer, but let me walk you through the steps. So 1 and 2 gave me 3, and then you have 2/3 plus 2/3. Well, they have the same denominator, so you can keep the denominator, add the numerator, so you get 3 and 4/3. Does everybody understand the first step? Okay. But now we can rewrite this and break it into two parts, the sum of the whole number with the fraction. And then the fraction part is an improper fraction. So I can rewrite that as a mixed number. So 4/3 is equal to 1 and 1/3. Okay? Now I can put the whole numbers and add those. So 3 plus 1 and 1/3 is 4 and 1/3. Okay? I'm breaking it down a little bit more than the book. Okay? Just a little bit differently, a little bit more, because I know there's a lot of you that are missing some gaps, that you have some gaps in what the steps are. Any questions about the first problem that Tori just gave us the answer to? Okay. Who wants to share with the class the second problem? Kalila.
I got 5 and 1/2.
5.5 for this one?
And what 5 and 1/5?
5 and 1/5. Well, what problem you're looking at? Are we looking at the same one? It's 1 and 2/5 plus 3 and 2/5. Is that what you wrote down? Is that what you started out with? 1 and 2/5 plus 3 and 2/5? Okay, double check what you wrote down, and then let me see if I can get. Quinn, can you walk me through this problem? What did you get?
I got 4. I got 4 and 4/5.
Okay, that's correct, 4 and 4/5. And you know what? We can't even simplify that anymore. It's done. 4/5 is not improper, it's a proper fraction. 1 plus 3 is 4. 4 and 4/5, that's the answer. And who's got this last problem right here? Trinity.
1.
The answer here is 1. Okay, so 5 minus 4 is 1. I have a half and a half. Since they both have 2 in the denominator, 1 minus 1 is 0, so 1 and 0 halves. Well, 0 halves is nothing, so 1. Are we good? Any questions about that problem? Okay, moving along. Now, this is a model that represents the sum of 1/4 and 1/3. And it tells you it's equal to 7/12. Okay? Now, if you notice, it's a little different than the problem we just did, right? The problems we just did, how are they different to this problem? How are they different? Kirsten, how is this sum of fractions different from the fractions we just did? The denominators aren't the same, right? Okay, very good. So take a look at my model, and I'm going to go ahead. And we want in order to add fractions, we need to have a common denominator. In order to take the difference of fractions, we need a common denominator. So let's go ahead and do that, and I'm going to connect that with the model. So 1/4 and 1/3, what's the least common multiple of 4 and 3? Class? 12. Is it always going to be the product of the two numbers? No. So 4 and 3, the LCM is 12. So the LCD we're going to use is going to be 12. Now, how do I write 1/4 as a fraction that's equivalent with the denominator of 12? What's going to be the numerator of this fraction? What is it? 3. So 3/12. Okay? So that is what's replacing that fraction. And so over here, I'm going to take the sum of 1/4, which I rewrote as 3/12, and I'm going to add that to 1/3, but 1/3 needs to have the same denominator, so we need it to be a 12 in the denominator here. What's the numerator going to be so that's equivalent to 1/3? 4. Very good. So now we have the sum of 3/12 plus 4/12, and what's that going to equal? 7/12. And if you look at the model, if we take a look at our model, this is what we have here, over here. You see that? And then over here, we have okay? Do you guys understand? Yes. All right. Questions? A day. Questions about this problem? Kalila. You already went twice. I got your name on here twice. Okay, moving right along. The difference. Now, if you notice here, they took them and they stacked them together, but here they overlapped them for the difference. Do you guys see that? Yeah. Let's rewrite a half so that it's got a denominator of 6. And what's that going to be? 3/6 is the same as a half, okay? And so if we look up here and we rewrite this, and then we got this other fraction, 1/3. Well, I need to rewrite that so it's got a 6 in the bottom. What's my numerator going to be so that it's equivalent to 1/3? It's going to be 2. So I got 2, 6, okay? And the difference of these two is going to be 1/6. Okay, so I just wanted to explain the model to you. Let's go ahead and continue on. If they have a different denominator, we need to find the LCM. Can you guys go ahead and work that out really quickly? LCM to find the LCD, yes. Which one? For the difference? So do you see how they overlap, Quinn? The part that they don't overlap is 1/6. Okay? In the sum, we just stack them next to each other. For the difference, we try to see if we stacked them, what was extra. Okay? A little bit different thinking with that model. Quickly, let's work this one out. Okay, about a quarter of you still writing. Does everybody have at least the LCD? What's the LCD going to be? 15. Okay. And so what's 4/5 going to be when I rewrite it so it's got a denominator with 15? 12/15. What about 2/3? Okay, so here's what you should be thinking mentally, and this is what you should end up with, right? And then when I simplify that, what do I get? 22/15. And then, is that my answer? No. What type of fraction is that? So what's the mixed number going to be? Now, I do show another method where I break the fraction into two parts, because some of you guys showed me this on the quiz that we had, and some of you guys actually divided and put the remainder in the numerator and so on. So I'm showing you another method that's kind of in line with what the book shows, but there's two methods. You can divide this out using long division, show your remainder as the numerator, and then your quotient would be the whole number, and your denominator would stay the same. But are we good? Do you guys understand how we got this answer?
Yeah.
No.
Okay, question.
Where'd you get the 15 over 15 from?
What's 15 plus 7? 22. So I just broke it up into a whole number plus what's left over. It's just another way to do it.
Just like the division thing.
Right, exactly. That's what I was just saying. Okay, let's move along. Now, find the sum and the difference of these two fractions really quickly. Let's do this. Really quickly. Work them out. For the first one, what's the LCD of the first problem? It's the first one. 12. What's the LCD for the second one? 14. So when I rewrite the first problem, what do I get back? 3/4 becomes what? 9/12. What's 1/6 become? 2/12. Okay, very good. And then for the second problem, the LCD is going to be 14. So do I have to rewrite both problems, both fractions? No, I just got to do the 3/7. What's 3/7 going to become?
6.
Okay, so does everybody understand how we got to this point for both problems? Any questions about this? Okay, for this problem over here, the first one, who can walk me through the rest of this? What's the answer going to be, Taylor?
For the first one, 7/12.
7/12. So you guys agree? That's correct. What about this one over here? What's my answer for this one going to be? 11/14. Kalila, what's your question?
Never mind, I got it.
Okay. Okay. Next question. Read that to yourselves. Answer the question. There's a key word in here that tells us what operation to do. Can somebody tell me the key word? Jayla. Reduce. And can somebody tell me what reduce is telling us to do? Nathan? Subtract. Can somebody tell the class what the LCD is going to be? Olu.
16.
Very good. So, Olu, do you have the answer? Can you get us there? Who's got the answer? Tori? Are we good?
Yep.
Follow along. Is there any steps here that you're confused on? So 16 is the LCD. That means I only had to change the fraction 7/8. And then the factor that would allow me to do that is 2. I multiply the numerator and the denominator by 2. That's what I'm doing here. That gives me 14/16. And then I take the difference of the numerators because I have a common denominator now. 14 minus 9 is 5, 5/16 inch. Okay? Okay. Read this. Find the answer. What's the key word in this problem? It's kind of hidden, isn't it?
No.
What is it? Kalila. Nope. Who said that? Say it again. And. What's and mean? Add. Okay. Who's got the, what's the LCD going to be? 8. You can probably do this mentally. What's the answer going to be? Okay. Any questions about this problem? Because I'd like to get into the mixed the mixed numbers that have different denominators. Okay. So far, it's been pretty easy. Different denominators. You guys see what you've learned throughout the class so far. See if you can apply it here. Fractions in mixed numbers may have different denominators. You can use the least common denominator to rewrite them as fractions with common denominators. Can you tell the class what the LCD is going to be? 12. Mm-hmm. So, can I get somebody to walk us through this? Jeremy, I don't think I've heard from you today. Can you walk me through it?
So the LCD is going to be 12.
Mm-hmm.
And so to change the numerator, the new numbers for the numerator is going to be for 4 1/4 is going to be 3 12ths.
Okay, very good. So 1/4 becomes 3 12ths. Yes. What about 2/3?
Becomes 8 12ths.
Becomes 8 12ths. Very good. And here's the work that goes behind that and the factors that we use to convert those fractions to their equivalent fractions. Now what do we do?
And so we add 3/8.
Uh-huh.
And then so we have 11 12ths.
Uh-huh. And what about the whole numbers?
The whole numbers would be
So just look at the whole numbers, ignore the fractions, take the sum of those two. What do we get?
7.
So 7 and 11 12ths. Okay? Now, do I need to, is this an improper fraction or anything?
No.
No, so I can just rewrite it that way, 7 and 11 12ths. Okay, we good?
Yes.
All right, let's move along. Let's go ahead and answer these problems right here really quickly. Two a day is all you get. Okay, who's got the first answer? Go ahead.
No, but I got the rest of my figure.
Who's got the first answer? Tori, go ahead.
Okay, so the answer is 1.
Yep. The answer is 1 for the first problem. Okay. Who's got the second problem? Quinn? What's the answer? Who thinks they have the answer? Taylor?
12 and 124.
Let's see what we got. 12 and 1/24. Okay, and then this problem, 6. Almost done with the lesson. If you have some questions, take a look at the notes. I do break down all the steps here, but do you guys see how we got a common denominator? And then it's just like the other problems with mixed numbers. I think number 1 was a little bit tricky, but not too bad. Any questions about that? All right, so here we go. Last 2 problems. Let's go ahead and do this one. And then you could look at the notes for the last problem. Actually, you know what? Let's skip ahead to the last problem because this one's in the book. Go ahead and do that one really quickly. That one's not given to you, so try this one so you can see if you can get it. Now this one's a little bit different, okay? So if you look back at the previous problem that I told you not to do, we had to get a common denominator here. 9 was the LCD. So I rewrote 2 2/3 as 2 6/9. But then what happens is I have 6 1/9, and that's clearly greater than 2 6/9, but I can't take away 6 from 1. Do you guys understand? So I had to do some regrouping. So I took away 1 from 1 whole, and can I rewrite 1 as a fraction?
Yes.
I can rewrite it as 1 equals 9/9, right? And then 9/9 plus this gives me 11/9. So do you see what I did? Do you guys understand what I did?
Wouldn't it be 10?
I'm sorry, hold on. Did I mess up? 9, 5. Oh, no. I did trip up, didn't I?
Yeah.
9 plus 1. That should have been a 10. So I do need to fix that. All right, are we good?
Yep.
Everything's fixed now? Okay, so you have to do the same thing down here. Quiet, please. The same thing goes about here. So if you notice, I have to take away 2 5/6 from 4 2/6. Do you see that? I can't do that. I have to regroup things around. So I pull out this 4, and I need to pull 1 out, and it needs to be 1 that's equivalent to a fraction that's got a 6 in the denominator. And what would the numerator have to be? 6. So if we move along, and we're almost out of time, so I want to go ahead and get this. 6 6 plus 2 6 becomes 8 6. So do you see why I dropped this whole number down to 3? Do you guys understand? So I got this, and then this is what I get back. Now I have a fraction that I could take the difference of. So 3 minus 2 is 1. 8 minus 5 is going to be 3. So I get 1 3/6 equals 1 1/2 feet.
Yep.
Okay? Are we good? Yep. That's the 2 lessons. I have some questions. What's your question?
I got a negative number for the fractions instead of powering.
You have to regroup. You shouldn't have a negative value. Tori, question. No, you can't.